Okay, this is a decent example that I can give you. It shows you how I can simplify, and of course these are gases. It shows you how I can simplify questions so that they can be done at the 2-hour exams. I'm not going to give you something that's going to take all hour when I only have 1 hour. Scratch what I just said. Okay, and now I've given you this. I've told you that delta G from the table on the back of the book happens to be 0. Oh, that would be per mole. It doesn't really matter in this case because I've got 1 mole of stuff. And so I've given you this, and now I'm like, how much A and how much B do I got? That's the question. Okay, so, and especially you have to do this with ammonia on your homework. That's a little bit more complicated. And notice that to make up for that, I gave you the answer as part of part 4, but I just want to walk you through that. Okay, so what we need to do is build a table of what we have before and after, figure out mole fractions, build the equilibrium constant, plug it into the delta G equation, which at the test will be in the back sheet, which is something a lot of you missed. A lot of you were struggling to try to write down equations that were actually on the cheat sheet, not smart. You need an equation, it's on the cheat sheet. I work hard to make sure of that. Anyway, blah, blah, blah. Okay. You use the equation, you figure out what the extent of reaction is, and that's the answer. Okay, now before the reaction occurs, I could work with 1 mole or 2. I'm going to stick with 2N just because it's going to make things a little bit easier. I like that because I have a 2 here. Just makes more sense to me. I don't have to do it that way. I'm just going to do it that way for the heck of it. 2N. And when the reaction is complete, I will have alpha N. Alpha goes from 0 to 1. That makes a lot of sense because at most I could have 1 mole. At the least I would have 0 moles. And of course 2N minus. 2N minus, oh yeah, this is actually, I was about to say minus alpha N. That's wrong, right? That minus 2 alpha N would be the after. See, a little tricky, right? Check yourself. See what I did? I did this, what I was going to do is I'm going to do this minus that, but that wouldn't be right, because that would leave 1 mole of A behind if the reaction was to completion. I just wasn't doing it right in my head. So I fortunately checked my notes, but then again, if alpha was 1, I should have 0, and that's 0. Okay. Next step, total. Okay, that's pretty easy. I'll write it out just so you see what I'm doing. I don't want you to get confused at all. Of course, this is 2N minus alpha N. Okay, that's pretty blind. And now the mole fraction. Mole fraction is the number of moles over the total. And if you're doing this right, here's another way to double check yourself. The N should always cancel. You should have alpha, you should have some alphas, not any N alphas. Just to, I mean, it's kind of impossible for that not to happen. Again, that's my point. But if somehow you have messed this up or messed this up, your N's won't cancel. Again, it's a way to double check yourself. Okay, now we figure, here, I'll toss this up and figure out what K is. And remember that this is a gas reaction, and I'm still going to tell you how you do all this for biochemistry reactions in solution in about 2 weeks. For now, we're just going to stick with gases. And I know that this is, I know that delta G changes due to mixing. And mixing means that partial pressures drop, and I know that delta G is proportional to partial pressure. All right, I'm just remembering that's how it was derived. You don't need to know that. What you need to be able to do is look at the equation in the back of the book. Okay, I've got products. Let me make sure. Yeah, B's on top, A's on bottom, so I'm just going to flip that. It needs to be squared. It needs to be squared because A's got a 2 in front of it. That's entropy doing that trick, by the way, remember that. I don't want to just start saying the derivation, but anyway, that 2 is there because of entropy, the natural log, anyway, whatever, let me just write it out. Okay, and let's see. And so this is PB over PA squared. And remember that there's the initial partial pressure of 1 bar is there because delta G changes by the dilution of A into B, and its initial partial pressure was 1 bar, and that has to be there because all the delta G I gave you was measured at 1 bar. So anyway, it also makes the units cancel, so I like that. But P0 is 1 bar, so I'm just going to drop it. You can drop it or not drop it. Again, it won't matter because it's 1 bar. I won't count off if you forget about it. Okay, and so then what I get is using Dalton's law. And of course, I put a reminder for that you need to do it that way. That is equal to the mole fraction, which you have defined above, times the total pressure. Now, again, questions I've seen in standardized exams, questions in the back of the book that I used to just assign, do questions 1 through 5 in the back of the book until I started writing them myself. I did that because you guys did a lot better if I did that. Wasn't that hard. It's traditional just to say, assume that the pressure maintains at 1 bar. I realize that that's kind of stupid in a reaction like this. It's naturally going to lose pressure. I think that's the case with your homework question. Okay, so that's total pressure. And you know that because I'm not labeling it any other way. Okay, so that means K is now, again with the mole fractions defined above, alpha. Okay, so I'm doing B alpha, the ends cancel, over 2 minus alpha. 2 minus alpha, right? Yeah, okay. Sorry, this is B. This is this part right here. The P0 we'll forget, so let's do 1 over the A. A is on the left. Okay, that's 2 minus alpha on top, squared, over 2 minus 2 alpha, right? Minus 2 alpha on bottom, that's squared. Minus 2, okay. And then we can simplify this to alpha, 2 minus alpha, cancel over 2 minus 2 alpha squared times 1 over pressure. Okay, so there you go. And now, again, the equation in the back of the book. You would need to go this far in some snarky way. I've then made this very easy. So again, you look at the equation in the back of the book. Delta G over RT is lnk. Okay, but this is 0. Therefore, K is, again, is 2 alpha minus alpha squared. I'm just carrying through that bottom part. Actually, let me expand the bottom. 4 minus 8 alpha plus 4 alpha squared is equal, e to the 0 is what? 0? 1, that's right, it's 1. Okay, notice what I've done here. Here, I'll toss this up in a second. What I've got is, I've just done the algebra. I'll toss this up in 1 second. What I've done is I've set this up. I set myself up a quadratic equation. Right, see how I did that? Again, the point being here is that anything I put on the test will be engineered and rigged such that the answer will just kind of come out relatively easily. Now, I would not remotely do a question. By the way, this is a little too hard. I would not do a question this hard. It's not exactly hard to figure out how I can simplify it further, but I'm just going to stop there, all right? Regardless, notice how it's a very simple example problem. You end up with a quadratic equation. You solve this, hopefully, in high school, and there you go. There's the answer. The answer also makes sense. It's a little over half, right? So what I'm seeing is it goes a little bit beyond half. Now, okay, This was part A. Part B says, again, test-taking strategy. Part B says, why does it make sense that it went a little over half if this was on the test? Two things. One is the question. Two, it gave you the answer. You should have gotten above 0.5. That's what it's directly telling you. If you didn't get that, then figure it out or go do another question and come back to it. The reason it makes sense, and this is related to the test, one of the questions on the test is that by A, a little bit more than half A forming B, there's more mixing, right? You create more diversity because, I mean that's exactly what's going on. Yeah, you just have more entropy by forming a little bit more B because you've got two A's to begin with. So it's like saying you want to shed some A, you want to get rid of some A, so that you can mix more of B, and everything wants to mix. And that's because you have a little too much A to begin with. You can also think of it like the Shapley's principle. You've got more products, so you get a little bit more reactants. Again, that's why you got a little bit more B than you probably initially thought. I bet you thought it would have been half. And that's another thing. You should have figured it should have been around half. Now that makes sense. If you got like 0.0000001, if these go haywire, you're going to get a crazy number, all right? You should see that this, delta G of 0 means you're at equilibrium. And that means it ought to be around half. You don't get something close to half, then you're not right. Now, if you did get half and part B says, why is it a little over half? Again, you've done it wrong, all right? Anyway, test-taking strategies. Now, homework. Homework throws a curveball at you. And where is that? Where is that? Okay, it's right up here. Okay, so here's the curveball on the homework. Where's my little? Okay, so this is like question 2, I think, that I've just done. Yeah, this is question 2. Sorry, question 2 is a little bit harder. It's ammonia. And you're just going to assume, you just leave pressure alone. Notice that I dropped the one over pressure. I dropped this factor when I solved it. Notice that? Okay, question 3 says, what happens if you don't? And what you do there, let's say if P is P naught, if alpha equals 0, okay, so basically what I'm saying is I start the reaction at 1 bar. That's how I'll express it in the question. If I start the reaction at 1 bar, and this is in a metal vessel, what will happen is if the reaction goes to completion, I should have half a bar. Okay, so I have to come up with a phenomenological model for pressure, which does that, which is 1 minus alpha over 2. So if I put this on the test, what I'm testing is and this is like a crossword puzzle. And again, I'm very tempted to put something like this on the test. I tell you how the starting point is, and of course I'm going to make it a bar. You should be able to figure out if the reaction goes to completion that you should have half a bar, and ergo, right, if alpha is 0, this is 1, if alpha is 1, this is a half, right? This totally works. This is correct, all right? Now what you do is guess what? So e to the 0, and I'm doing the minus delta G over RT ln I'm doing that. E to the 0 is 2 alpha minus alpha squared. I know my 2's look a little bit like alphas. Be careful of that. All right. Obviously, on the exam, the fonts are well written. Okay, so I've got what I had before, plus 4 alpha squared. And in addition to that bit that I had ignored, 1 minus alpha over 2. Now then you solve on Mathematica, and okay, I'll write that down. Okay, I have no idea how you solve this. I mean, I know I did it in high school, freshman year. I have no idea how you solve that, so I use Mathematica. Guess what? It's exactly a half. See, I engineered this question to do that, by the way. See, that actually makes sense, and this is why I'm a little bit upset at those standardized test questions that just say, oh, just assume the pressure is maintained at 1 bar. Again, that requires the reaction to be done in an accordion-like device, which is weird beyond words. I don't know who or how you would do that. I guess, well, you do it in an accordion. But of course you wouldn't really do that. And look what happens if you don't. You get a sensible answer, right? That totally makes sense. So, and again, you're free to carry through this on your own or do the homework as is. And notice in number 4, I did give you, it's a real nightmare problem, so I gave you the answer. Yeah, anyway, any questions? We're okay? Yeah, all right, so electrochem, let's go to electrochem, and then let's do the test. I'll stop the video after the electrochem. And normally I don't do this, but I want you guys to bend a little bit for me. I don't know what we need to do to get the grades higher, and I promise you I wouldn't scream at you, just a little bit. I'm a little disturbed that not enough of you come by office hours. This is a relatively small class. Normally I have about 120, so I expected less people, obviously, at office hours, but there are sometimes I only have 2 people, and that's really unusual. And I'm thinking, oh, I guess we're doing well, and that's not the case. So I think more of you need to come by office hours. I am also scared, as I've said many times, but it bears saying again, if you're getting your answers from someone else, you're dead. And I've said that. So if you're going to keep doing it, there's not much I can do about it. So do not do that. Try problems on your own. And after you get stuck on something and you're frustrated for like an hour or 2, stop, because that's a waste of time at that point. And I don't want you losing any kind of enthusiasm. At this point, that might be foregone. But anyway, I would want you at that point to work with a partner, right? It's bad to start out with a partner, but it's bad not to have a partner at all, right? And chemical educators have shown you that. Okay, so electrochem question. Here's an electrochem question, which this really shows to me whether you get it, whether you understand the big picture. Okay, here's a true and false question. Big picture is that these electrochem questions are Hess's law questions with a different reference. That's really what it comes down to. Now that being said, that means I can throw curveballs at you. Normally I don't tell people I'm going to do this, but with your class I will. That's okay. I can bend again, as long as you do as well. Okay, so I gave you this information. I said I've got A in a pocket in one of the sides of the Daniel cell, of my battery cell with the salt bridge. And it'll go, I know you're thinking, well, it just goes to neutral A. Let's say it's B. It doesn't matter. I'll explain why I'm doing that right now. Let me give you the EMF. Of course, I will make it easy. 2. Let me not do that in case it gets confusing. Plus and minus. If I don't put anything, it's plus, obviously. Okay, now, here's where I screw you. A plus 2E goes to C. And the voltage is 1. Okay, so I told you again, you're at the 3rd test. This is in one side and here's in the other. I have D. Again, I have to write these in the form of a reduction potential. And it goes to E. And that voltage is minus 1. Standard reduction potential is minus 1. Okay, so now notice the curveball is you don't know what happens here, right? Normally this is actually, you had this in analytical, maybe freshman and high school. I don't know that I had this in high school. I know that it's in freshman, and I know it's in analytical. That if I simply just gave you 2 options, it's kind of childish. I could train a dog to do this. By throwing you a curveball, it shows me whether you really get it or not. What you have to do is figure out which one of these 2 is going to happen. Now the reason, by the way, I do this ABC deal is that if you're thinking like, well, this couldn't happen, oh God, no, you're wrong. Look at standard reduction tables and you will on some, well, no, I give you the information on your homework, so don't worry about it. But anyway, Google standard reduction tables and you will find that things like oxygen and water and several others, cerium, I think as well, there are actually multiple entries. It can depend on like what counter, so notice that I'm being very generic because maybe this is sodium plus chloride versus sodium plus potassium plus chloride. Anyway, there can be multiple things that A and B and C represent to allow multiple different reactions to occur. That's reality. So when you're designing batteries, you actually have to be aware of all the possibilities and figure out which one happens. So anyway, let me work this problem, and then we're going to move on to the test. What I want to, okay, here's another curveball question, because this isn't really that hard, but let me work it just so you know what to do. But now I can already, I'm looking at this, I just thought of a third, just thought of this. Now this is how I write tests. I'm often writing a question, I take the old test and I rewrite the questions, usually kind of in a fairly trivial way, you know, instead of DHDP, it's DUDP, right? And then like every 4 or 5 years, I actually code full circle, whatever. But sometimes I'm looking at questions and I come up with something brand new and I just thought of one. Okay, so I had you do this in number 2, and here's the question in number 3. Having established that this one is, by the way, this is the winner, right? No matter how, no matter which way you do this, this one has to win. It's the most positive. If it was negative, I would flip it, and then it's the most positive. Anyway, this is the winner. Now the question is, does this reaction occur not at all? What do you think? Not at all, or maybe a little bit? Right, it would occur a little bit. Right, just because this isn't the winner doesn't mean that this is still not happening in that right-hand cell, whichever side it's in. And here's how you could know that. Okay, remember, I said you're allowed to think in extremes. If that's the curveball, again, this is the winner, and I said, and you analyzed it in question 2, and question 3 said, well, does the loser on the one side, does that just not happen at all? The way you think of this is, what if this number was 1.00000000001, right? What if it's just barely above this one? Would it make sense to you that this one would happen? You know, of course, the wrong answer is it doesn't happen at all. In your mind, you know, it's look at this. It's already 2 and 1. I just wrote it arbitrarily. It's obvious I just made up numbers. What if I had just made up 1.000000001, right? Obviously, they basically both would happen. I could just keep adding zeros. So the answer is this would happen. Now the reason that we don't really worry about this is that, remember that these are actually delta G's, and as we get into Chem 344, which I very much would like all of you to be there, you would know that reaction barrier scale is e to the delta G. And remember Arrhenius equation, you're going to have it in PChem lab, we're going to have it next semester. The fact that this is twice as high doesn't mean that this happens twice as much. It'd be like e to the 10 to the 2 as much, 100 times, right? So this will happen, but it really will be quite small. And this difference in EMF is pretty big. Actually, it's kind of gigantic. So anyway, that's just an example of the way I think of questions, curveball questions, and and look at and a way for you to answer them. So, all right, now in terms of how you answer this, let's see. Okay, first we write down minus the number of electrons times the EMF. Sorry, I don't think I spelled it out because this is delta G. Remember, over Faraday's constant, but I don't care. Symbology, I don't care because I get it wrong a lot myself. Okay, and so this is minus 2. Am I doing this right? Minus 2. And this is, of course, minus. No, this is minus. What have I done? What have I done? I've done something a little funky here. This is, now I have to admit, I'm a bit confused. I know that this is the winner. This is the winner, but why would this not? Now I have to admit I've kind of screwed myself. Well, one thing I need to do is I need to reverse this one. Let me do that. I'm going to have E goes to an electron plus D plus. Okay, now that I know I have to reverse that one, so that's plus a volt. And so this ends up being minus 1. Okay. Now I remember actually every year I get screwed up on this. Every year I give this example. This is the winner, but the reason I am not good at this is because every time I do this I actually get confused why this is actually not going to work. And why the heck is that? Now I'm kind of freaking out.
On the second one, wouldn't you need to manipulate the bottom to get 2E also?
Yeah, you would, and then you wouldn't have any delta G, would you? Right, that's why. Yeah, thank you. No, there's more to it than that. But right, so if you did the stoichiometry correct, you would have two of these. Now this number would be the same, but then you would end up with -2, and that would be -2 minus 2. That wouldn't, no, that would actually still work. No, but then you'd have to, what the hell have I done? Imagine that nine. No, this one and this one actually still produce the greatest combination because yeah, when you do this one and this one, when you scale this one, you'll end up with a greater voltage. Right, that is the answer. You will end up with the greatest voltage if you work this one. And here, let me just do that. Where am I at? Got it. Sorry, folks. I can't believe I got it. I get this track every goddamn time. I swear to God, I get confused because I give myself this problem. And I did look at this before class, and I worked my way through it. And now I'm blowing it. So here, let's write out the different reactions. Let's just write them out so I don't get too confused. Let's do. I feel like I've done wrong. Let's A plus electron goes to B, and then let's add E goes to an electron plus D. Okay, EMF. Okay, I have not done anything with this. That's still 2. This is +1, +2, +1, minus this times the EMF, which is delta G, would be -2, -1, which ends up being -3, and therefore the voltage is -3 over 1 electron, by the way, which is 3 volts. Okay, so there you go. And of course, the net is A plus E goes to B plus B. Okay, and one way I've also, here's another hint, by the way, if I throw this curveball at you, one way I've screwed these up in the past and how I can figure that out is if I don't charge balance. I have a cation on the left, I need a cation on the right. So if you screw up your balancing, you'll actually blow that. You'll end up with like neutral on the left and a cation on the right. Look out for that. That's a way you know you've done it wrong, is that if you mess up your balancing here, your charges won't balance here as well. All right, so again, it's just a hint. And why don't I do the other example? I have to admit, I don't know how this is going to come out, so I'm kind of freaking out internally. Let's do the other one. Let's do the other one and show it doesn't work. A plus 2E goes to C, and that has an EMF of 1. And this is a -2. Okay, that's good. Now this guy we have to conform. Okay, so I'm going to have 2E goes to 2E. Sorry, I shouldn't have used 2E's, right? Sorry about that. I screwed that up on the exam as well, didn't I? Okay, so that's an EMF of +1 and an EMF of, okay, that ends up being -2, right? Okay, let's just write out the stoichiometry. Let's not worry about that because this is the loser. This ends up being -4. Yeah, you see? Yeah, it's right. So the voltage is -4. I'm not writing down the equation. Divide by the number of electrons, 2. 2. Right, it's the loser. It doesn't produce as much positive voltage. This is not as thermodynamically downhill as the other guy. So tell you what, you just saw me struggle with this. What I'll do on the exam, I will set it up into 2 parts where I don't have you Now, again, I knew that the top reaction of the two possibilities, the top one was going to win. I knew that. I knew that if I worked it correctly, I would show that, and I have done that. Thank God, because I was really freaking out. Okay, to make sure that you do it right, I will actually divide this up into a part A and part B. For one, you consider the one on top, and the part B, you consider the one on bottom, the A's, the A plus 1 electron, B plus 2 electron. I will have them divided into two sections. You will consider them both, and then question C will be which is the answer. We'll do exactly what I just did. Now, I'll probably pick something not A's and B's, but sodiums and potassiums or water, something relevant. I'll do something relevant, something real because that matters. And anyway, so this is how I'll walk you through it, because you just saw me kind of almost screw up. I think I almost screw up. Yeah? You all right?